We'll discuss in some detail the unique clause applied to the forEach command, knowing that it can also be used in groups of data providers and grids with a base table. Here we see it among the other clauses of the forEach. When the value of a set of attributes is repeated for many records, in this example, D and E, we can use the unique clause to work with one or all the records whose value is repeated, as if it represented the group. For example, printing the values of those attributes, since they'll be the same for all the records of the group, and then moving on to the next group to do the same, and so on until using all of them. For this to make sense, only attributes whose value is unique for each and every record in the group can appear in the code to be executed for each group. The attributes included there do not have to be part of the same table. They can be in the extended one. Let's suppose that this is a graphical representation of the extended table and not a physical table. For example, suppose that E is a foreign key that determines H and I. That is, this physical table exists. This means that for all the records in the group, since the values of E are the same, the values of H and I will also be the same. This means that we can also use the H and I attributes within the code that will be executed for the group, since they'll also be unique to that set of records. Let's see some examples. We have the trips that can be made to different tourist attractions with an assigned amount of time for each visit. We want to obtain a list of the tourist attractions included in these trips. Let's suppose that this is the current data from the tables. We'll want to list only these attractions. A first option could be to implement a control break that navigates trip attraction and groups by attraction ID. In this way, we can be sure that we're only listing attractions actually included in trips. Also, by placing the print command after the nested forEach, although placing it before would have been the same, we know that for each group, we'll be printing only the attraction name that's repeated. This can be solved in a much simpler way using the unique clause. It's the most obvious use case. In the navigation list of the forEach with unique, we see that since it has an index by attraction ID in trip attraction, because it's a foreign key, it'll choose to sort by that attribute. Therefore, it starts in the first group where the value of attraction ID is repeated, and its attraction name, which is unique for all the records of the group, is printed in the output, Louvre Museum. The next group is a single record, Eiffel Tower is printed. Then the attraction with ID 6, which is Matisse Museum, then 10, and finally 12. If we wanted these attractions to be sorted by attraction name, we could add the order clause. And so we see the navigation list. The single value being sought is still attraction ID, but the result of the query will be ordered by attraction name. Could we instead use the attraction name attribute directly in the unique clause? The answer is yes, but note two things. On the one hand, doing this does not ensure that the list is also sorted by attraction name. Note that the navigation list shows order none. Genexus doesn't know about the existence of an index by attraction name. So we should still order by attraction name if that's what we want. On the other hand, let's think about what would happen if we had two attractions with the same name in the database. For example, 1 and 8. If we don't have a unique index by attraction name, this will be allowed. And note that we have attraction 1 in 2 trips, and 8 in 1. The only difference between this forEach and this other one is the unique clause. In the first case, these two records will be handled together, and Louvre Museum will be listed. And this one will be handled separately in another group, and Louvre Museum will be listed again. In the second case, however, the 3 records will be in the same group, and Louvre Museum will be listed only once, even if it corresponds to 2 different attractions. We can see this very clearly if we imagine the data like this, with the extended table as a super table. If we order it by attraction name, we see it more clearly. Note that there's no problem with the attribute of the unique clause being in the extended table and not in the base table. In short, it will not be the same to ask for unique values for attraction ID and for attraction name. If the unique index exists, then the result of both for each commands will be exactly the same, because this record 8 cannot possibly exist. In addition, we can not only keep one of the repeated records to do something with the information that doesn't vary, like printing it, but we can also run aggregation formulas on the repeated ones, for example, to count them. Of course, the formula must navigate the same table. So, we take the first group and run the count on its records. It'll give 3 in this case. And it prints D and E, information that's unique to that group, and 3. Then the next group, for which the count will give 2, then the third one, for which the count will give 1, and finally the fourth one, for which the count will give 3. In this example, besides keeping the non-repeated attraction ID to list its name, we want to count how many times it's repeated. In short, the number of trips where it's present. The count formula is using the secondary attribute of the table you want to navigate. So when this is determined, the count formula will have a special behavior. It'll group by the unique attribute as we see in the navigation list. Remember that for the list to show the navigation of the formula, we must activate the detailed navigation through Tools, Options. Then, for each group of repeated ones, it'll count the records for that given attraction ID, that of each group. Thus, the first group with repeated attraction ID is obtained, its records are counted, those with the same attraction ID, and the attraction name and that number are printed in the output. Then the next group, for which the count is 1, then the next one, which gives 2, the next one, with the same name as the first one, gives 1. The next one also gives 1. And the last one too. On the other hand, if instead of attraction ID, we use attraction name in the unique clause, then the group corresponding to Louvre Museum will count 3 records. In the navigation, we see given and group by. Let's look at this particular case. If there's no secondary attribute in the table we want to navigate, then we may have to do something so that Genexus understands that we want to navigate that table for the formula. That is to say, if, for example, we place the trip ID attribute for the count, and in unique we leave attraction name, Genexus may not choose the trip attraction table to solve the count formula, but trip, and the result will not be the desired one. It's reported that it will navigate the trip table and count all the trips then, because there's no condition reported for the formula. It should choose to navigate trip attraction for it to do what we want. Since we don't have a base transaction for the formulas, we can use a trick. Add a condition that's always true and contains an attribute that causes it to determine the base table we want. For example, this condition that uses attraction ID and that will always be true. Note the navigation list indicating what we want. Now it's navigating trip attraction and also grouping by the attraction name given in the for each. Therefore, only counting the trip attractions of the same attraction name. Let's go a little further. We know that we can specify several attributes in the unique clause, and that they do not have to belong to the base table of the for each, as in this example. We want to count the number of trips that include a visit to the same attraction name on the same date. That is, for the same trip date and attraction name, how many records are there in trip attraction? If this is the data from the tables, we only show the relevant records, we see that for Eiffel Tower, there will only be one record in trip attraction, the one for trip 1, which is on this date. We have the Louvre Museum in these 3 records. When we look at the dates for trip 1 and for trip 3, they're the same. So in the output, we'll have, and for 2, it's this other one. So this will be shown in the output. Lastly, for Matisse Museum, we have trip 3 and 4, which, since they have different dates, will lead to 2 prints in the output. In this example, neither of the 2 attributes of the unique clause belongs to the base table of the for each. We could also use formulas in the unique clause, as long as they're global. For example, let's suppose we want to count the trips by attraction name according to the year of the trip. That is, for each attraction name, by year, how many trips it's in. We'll be tempted to write this unique clause, so that if we change the year of trip 2 for this other one, then the output would have to be as follows. Attraction name, Eiffel Tower, is only on one trip, so its year is listed, and the count will give 1. Then comes Louvre Museum, which is on 3 trips, the year of 1, and 3 match. So the output will show this. Since the year for trip 2 is different, this will be shown in the output. Then, we move on to the last attraction name, which is on 2 trips, 3 and 4, which are from the same year. So the output will look as follows. The problem is that we'll not be allowed to use an expression in the unique clause. We can only place attributes, as is clear from the syntax. But those attributes may well be formula attributes. Therefore, if the example had a trip year attribute, formula, and we used it in the unique clause, everything would work as expected, as shown in the navigation list. A restriction we saw is that only attributes, which can be formulas, but not expressions, can be used. Another restriction: only attributes that have unique values for those in the unique clause can be included in the main code or body of the for each. In this example, where we're asking for unique trip attraction values according to attraction ID, we see that these 2 records will be processed once, and Louvre Museum will be displayed together with 2 as the count result. On the other hand, this other record will be processed alone, showing Louvre Museum, and 1 in the output. In the print block, it was possible to put attraction name because for each attraction ID of the unique clause, its value is unique. We could also place country name, city name, category name, that is, unique attributes for attraction ID. But if we had placed trip attraction visit time or trip date, we would get an error. There are more subtle cases that can mislead us. For example, what would happen if instead of attraction ID, we placed attraction name in the unique clause? With this code, there will be no problem, but it'll show something different than the previous one if there are attractions with repeated names, as in this case. The reason is that it'll group these 3 records and will show 3 as the result of the count. What would happen if, because of distraction, we put attraction ID in the print block? We would get the same error as if we put trip ID or trip date. That's because, from an attraction name, you don't get a single attraction ID. The restriction only applies to the body of the for each, not to the other clauses. In particular, it doesn't apply to the filters. That is, it applies to what happens after the records have been sorted and filtered. So, for example, we might want to list every attraction name included in trips after today's date, together with the number of trips they're in, and with the query sorted by attraction ID. If this is the data and the date of the today variable, let's think about what should be the result of the query. The trip attraction table is run through by attraction ID, but also the records that share the same attraction name are considered only once. In this case, for the first record, there will be these 4. But of those, how many will pass the filter? The first one does not. The second one does. The third one does not, and the fourth one does. If the count formula also includes the same condition, then the output will show Louvre Museum and 2. If we had not added the same filter condition for the formula, Louvre Museum and 4 would be displayed. Next, we go to the next record to process in the for each. It's the only one left, and its date doesn't meet the filter, so nothing else is processed. The final result will be this, depending on whether or not the filter condition was added to the formula. In fact, if we look at the navigation list, we can clearly see that the formula is calculated as we want. Let's look at the group by and how the where shows the filter on the records to be counted. If we remove the count condition, then the navigation list will inform this for the formula. Finally, let's mention the last restriction. If we use a unique clause, it only makes sense to nest another for each if it doesn't have the same base table. That is to say, we cannot use unique in control breaks, as one might think at first. So, for example, if we want a list of the attractions included in trips, with the duration of the visit to the attraction in each of those trips, we'll have no other option but to implement it as the typical control break. We run through trip attractions sorted by attraction name, and, for the first trip attraction record with the first attraction name, we print the attraction name. Then, we iterate through the records with the same attraction name, here, only this one. We print the date of the trip and the length of the visit, and move on to the next group, which is the one corresponding to these records with the same name in attraction. We print the name, and again, iterate with the nested for each as long as the attraction name doesn't change. And so the output is if we wanted to implement this with a unique clause, Genexus would not allow it. The navigation list would show this error. But we can nest a for each that navigates another table. For example, let's see this case in which we're navigating the attractions table, sorting by country name from the extended one, and asking to process only once all the records that repeat the value of country name. For them, we want to count the attractions of the same country, print that country with the number of attractions, and then navigate the hotel table, printing the names of hotels in the same country. So, with this data, the output will look like this. Here we have the attraction table sorted by country name. There's only one record for the country of the first record. Its country is then listed, and 1 for the count. Since there's no hotel in Brazil, it'll go on to the next record in attraction, which will be 3, corresponding to France. There are 3 records with the country France, so in the output you'll see, then the nested for each is run, and it'll print the hotels in France. Therefore, the output will show, and finally, we'll have the navigation list will clearly show that the implementation is as we wanted. Note the constraint of the nested for each by country name. Finally, let's mention again that, although we focused on the unique clause for the for each command, its logic applies to all other forms of queries.